We are describing in statistics. That's why it is called a descriptive statistics. Then inferential statistics. So here this involves drawing conclusions or making predictions about a population based on a sample of data. That means inferential statistics. This year 2023 India population is 140 crores. We are expecting a 2024 by the same time 150 crores. That means we are drawing conclusions or making predictions about our population. Then probability. Next concept is probability. This is the study of random events and their likelihood of occurrence. So the coin of 1 rupee coin, head or tail, there is a chance of getting probability 1 by 2. So that is called their likelihood of occurrence. Hypothesis testing, it involves we have a database and we are asking the query, or we are giving the question, or we are retrieving any information from the database. That means we are testing with the boundary values to the hypothesis or any database and claiming about a population using a sample of data. So we are asking what is the population of India population in the year 2023 in December. So we are asking the question, we are testing with one query. It is retrieving the information with a hypothesis testing, like it is retrieving the information. That is called a hypothesis testing. Sampling. Sampling, it involves selecting a representative subset of a population to collect data from. So I'm collecting only the Andhra Pradesh population from the whole India data. So I would like to calculate only Andhra Pradesh population out of India population. So I'm collecting population to collect data from the database. So correlation. Correlation is the measure of a statistical technique, the strength and direction of the relationship between two variables, like twin faces. You cannot differentiate between twin faces. It is very difficult to segregate. It is difficult to recognize two similar faces because almost all features are same, and maybe behavior is different. Maybe some cases height is different. Some cases color is different. Based on that features we can segregate. Otherwise it is a very difficult system, maybe confusion state based on the features. So correlation is nothing but relationship between the two variables. Regression, this involves modeling the relationship between one or more independent variables and a dependent variable. So suppose yesterday temperature is 30, today temperature is 40. So tomorrow I am expecting yesterday plus today by 2. That means 35. I am predicting tomorrow's temperature is 35. So that is called regression. Relationship between one or more independent variables and a dependent variable. Then confidence intervals is nothing but these are ranges of values that are likely to contain the true population parameters. That is called confidence intervals. That means range between one item to another item. So statistical significance is nothing but this is a measure of the likelihood that a result is not due to chance. Such type of concept is called a statistical significance. Experimental design is nothing but this involves designing and conducting experiments to test hypotheses and draw conclusions about population. That is called experimental design. So with the help of SPSS or SAS or ANOVA, ANCOVA, MANOVA, these all are statistical package for social science tools. Even R you can use, even you can use Python in order to perform statistical operations. And the fourth concept, there are 8 basic statistic concepts for becoming a data scientist. We need to have 8 concepts mandatory. The one is understand the type of analytics. Then second one is the probability. Third one is central tendency. Fourth one is variability. Fifth one is a relationship between variables. Sixth one is probability distribution. Seventh one is hypothesis testing and statistical significance and regression. Coming to the understand the type of analytics we are generating, I have already explained the descriptive analytics by summarizing the data. By conclusion, we are performing statistical operations like mean, mode, standard deviation, average, maximum value, minimum value, etc. That is called descriptive analytics. Diagnostic analytics is nothing but before going to the actual experiment, we are testing with the prior knowledge, whether it is able to do or not. It takes descriptive data a step further and helps you understand why something happened in the past. That is called diagnostic analytics. I'll give you a small example. Before going to perform the data science concepts, you must have prior knowledge on mathematics and statistics. So I'm conducting basic mathematics and basic statistics concepts as a test. That test is called a diagnostic test. From that test, we are generating interested analytics. That analytics is called a diagnostic analytics. Then predictive analytics is nothing but we are predicting the future value based on the past values. What is mostly like to happen in the future and provides companies with actionable insights based on the information. That is called predictive analytics. Then the prescriptive analytics is nothing but it provides recommendations regarding actions that will take advantage of the predictions and guide the possible actions toward a solution. That is called prescriptive analytics. Then the second concept is probability. So likelihood of the getting the events, like probability is the measure of the likelihood that an event will occur in a random experiment. Randomly you are throwing a coin. It may fall a head or it may fall tail. So the probability of the coin is 1/2. So there we are performing complement, intersection, union. Complement is nothing but see P of A having elements and P of A dash equal to 1. If it is satisfies, we can call it as a complement. Then intersection between two sets, we are having a common elements is called a intersection. Union is nothing but we are having a P of A contains elements, P of B we are containing elements, and both the combination of elements we can call it as a union. Then see the conditional probability. P of A by B is a measure of the probability of one event occurring with some relationship to one or more other events. So usually we are representing conditional probability. P of A by B equal to P of A intersection B by P of B, where P of B greater than 0. Then only conditional probability can work. Independent events is nothing but two events are independent if the occurrence of one does not affect the probability of occurrence of the other. That means P of A intersection B equal to P of A multiplied by P of B, where P of A not equal to 0 and P of B not equal to 0. Then we are performing independent events like P of A by B equal to P of A comma P of B by A equal to P of B. That is called independent events. Then mutually exclusive events. If you are taking two events are mutually exclusive, if they cannot both occur at the same time, that means P of A intersection B equal to 0 and P of A union B equal to P of A plus P of B. That is called mutually exclusive events. We are going to use these all functions in one example in the forthcoming slides. Bayes theorem is one of the statistical technique like it describes the probability of an event based on prior knowledge of conditions or constraints that might be related to the event. That is called Bayes theorem. In order to represent these events, we are using the formula called posterior probability and prior probability. So P of
Doctor,
A by
I have a question.
yeah,
Doctor.
please ask me. Yeah, Bayes
So
theorem.
when you look at this probability of A intersect B is equal
Yes.
to
Yes.
probability of A multiplication of probability of B over A. That's what
Yes.
you say at the bottom. But on the
Yes.
independent events, you have
Yes.
probability of A and probability of B.
Correct.
So the bottom is it says like probability of B over A.
Correct.
So is there a difference between independent events, the formula as well as the Bayes theorem formula?
Correct. Correct. Yes, exactly correct. Where A and B are events and P of B not equal to 0. Then only this posterior probability, prior probability. Exactly, Sundar. What you told, correct answer. That is called Bayes theorem. For classification and prediction, we are using Bayes theorem. Then
Oh,
the
yeah.
third concept. Yeah.
Yeah, you said B over A is equal to B. Yeah, I got it at the bottom. Yeah,
Yes.
the probability of
Yeah,
B
yeah,
over A.
yeah. Then central tendency. So here in central tendency, we are calculating mean, median, mode, skewness, kurtosis. Last class also I have explained skewness and kurtosis. So based on the central tendency operations like mean, the average of the data set, median is nothing but the middle value of an ordered data set. Data set is a combination of rows and columns. Mode is nothing but the most frequent value in the data set. If the data have multiple values that occurred the most frequently, we have a multimodal distribution. This skewness is nothing but a measure of symmetry, and E is nothing but kurtosis. So E is nothing but kurtosis, a measure of whether the data are heavy-tailed or light-tailed relative to a normal distribution. Sundar, 1 minute. I got call from friend. 1 second.
Sure. Go ahead.
Yeah, Sundar. Yeah, now I'm available. Sorry for inconvenience.
No worries, sir.
Yeah. So now, if you see the kurtosis, my screen is visible, Sundar.
Yes, sir.
Yeah. So a measure of whether the data are a heavy tail or light tail relative to a normal distribution. Like see here, we have like three types of sinusoidal curves. So based on the values, if it is greater than S kurtosis, then the blue line can occur. Then the S kurtosis equal to 0, then you will get the black line. Then yes, kurtosis less than 0, you are getting a red line. That indicates the central tendency values where it is falling, whether it in the case of normal distribution. If you see the fourth concept is variability, it changes the value during the execution time, like range, percentiles, quartiles, and interquartile range. If you see range, the difference between the highest and the lowest value in the data set, that is called range. Percentiles, quartiles, and interquartiles range, that is called IQR. We are performing three types of concepts in this IQR, like percentiles, quartiles, quantiles, and the interquartile range. What is meant by percentiles? A measure that indicates the value below which a given percentage of observations in a group of observations fall. So like out of 100 students, 90 students presented, the percentile comes under 90 percentile. So then quantiles is nothing but values that divide the number of data points into 4 more or less equal parts or quarters. That is called quantiles. Interquartiles range IQR is nothing but a measure of statistical dispersion and a variability based on dividing a data set into quartiles like IQR Q3 minus Q1. If you observe keenly in this diagram, IQR is nothing but Q3 minus Q1. That means Q2 is a median and below Q1 we are having a minimum value. After Q3 we are having maximum value. So that means so between Q1 and 1.5 IQR. So that is called minimum value. Between Q3 plus 1.5 IQR is called a maximum value. Then the variance is nothing but the average square difference of the values from the mean to measure how spread out a set of data is relative to mean. That is called variance. Then the standard deviation is nothing but the standard difference between each data point and the mean and the square root of variance. Like in order to calculate population, what is the variance? Sigma square equal to sigma of xi minus mu whole square by n. N is the total number of data points. Then for population, we are calculating standard deviation sigma equal to square root of sigma xi minus mu whole square by n. Then sample in the case of variance, S square equal to sigma of xi minus x bar whole square by n minus 1. S equal to square root of sigma of xi minus x bar whole square by n minus 1. So this is called standard deviation formulas. Then standard error. Why do we want to calculate standard error? In order to calculate any clustering and clustering classification regression, if you are decreasing error rate, that means automatically we are increasing the accuracy. An estimation of the standard deviation of the sampling distribution is called a standard error. That is called SC. So in the case of population, in order to find out the population operations, we are performing standard error. So sigma x bar equal to sigma by square root of n. We are estimating sigma x bar more or less equal to s by square root of n. For sample standard error is s of x bar equal to s by square root of n. Then if you see relationship between variables, causality, covariance, and correlation. These are the three important concepts we are studying, relationship between variables. Causality is nothing but relationship between two events where one event is affected by the other. That is called causality. Then see nowadays, so recently pneumonia variant came in the China. Per day 7,000 people are affecting, especially children are unable to breathe properly because of pneumonia virus. So virus is a vital information resource under seas. Computer virus is different than that normal pneumonia virus, COVID-19 virus, Omicron virus. So these are very deadly dangerous viruses. That means two events where one event affected by the other. That is called a causality. Covariance is nothing but a quantitative.
So on your research, the virus, what was the other effect? What event that was a relationship with those pneumonia virus?
Yeah. So see, pneumonia usually we are getting due to cold or due to virus. So it spreads like anything. That means now that pneumonia is one event. With that pneumonia event, it is spreading like a COVID-19 virus. Here two events where one event is affected by the other. So in my case, one event is pneumonia and another event is COVID-19. That is the relationship between causality. Now researchers are unable to segregate which one is pneumonia and which one is COVID-19. Sometimes the features are same in the case of prediction and detection of pneumonia chest X-ray image. Some symptoms are similar to COVID-19. So it is giving a challenge for just like just like us, we are facing the problem in order to find out the features involved in the chest X-ray image of both the pneumonia and the COVID-19 virus. Next concept is a covariance, a quantitative measure of the joint variability between two or more variables. That is called covariance. Especially in matrices, we used to find out covariance matrix. Then correlation measure the relationship between two variables and ranges from -1 to uh, you can call it as correlation is nothing but to measure the relationship between two variables and ranges from -1 to 1. The normalized version of covariance is called correlation. How do we calculate the correlation? Covariance of covariance is different than a correlation. Usually correlation we used to use in a face recognition application, that is a twin faces. How the twin faces are a close relationship between two persons with similar behavior, similar features. Measure the relationship between two variables and ranges from -1 to 1. The normalized version of covariance. So we have a positive relationship, we have a negative relationship, and no relationship. That is called covariance and correlation. And usually covariance of x comma y equal to 1 by n of sigma n tends to I is equal to 1 to n of xi minus x bar multiplied by yi minus y bar. So this is the formula we are using. Correlation of x comma y, covariance of x comma y by divided by square root of variance of x multiplied by variance of y. So this is relationship between variables. Then the probability distribution, we have three operations like PMF, PDF and CDF. PMF is nothing but a probability mass function. What it does, a function that gives the probability that a discrete random variable, that means not a continuous variable, like our age is continuously growing, like discrete random variable means a number of defects in a software and counting the numbers is exactly equal to some value. That is called a probability mass function. Then probability density function is nothing but that is called PDF, a function for continuous data where the value at any given sample can be interpreted as providing a relative likelihood that the value of the random variable would equal that sample. That is called PDF. Cumulative density function is nothing but CDF, a function that gives the probability that a random variable is less than or equal to a certain value. That is called cumulative density function. If you see in this comparison between PMF and PDF and CDF, see the x-axis we have discrete and continuous values, and y-axis we have a cumulative and non-cumulative. So which probability distribution operation falls under which category? So like CDF and PMF and PDF. This is the way we are representing. Then continuous probability distribution, we have two operations we are performing like uniform distribution and normal or Gaussian distribution. Very popular concepts like continuous probability distribution. Uniform distribution is also called as a rectangular distribution. and is a probability distribution where all outcomes are equally likely. See in the diagram, you can take the x-axis 0 to x in between a and b 2 points, and we are calculating the uniform distribution 1 by f of x 1 by b minus a. So it is making distribution with the equal outcomes are equally likely it will happen in the uniform distribution. Whereas normal or Gaussian distribution, the curve of the distribution is bell shaped and symmetrical and is related to the central limit theorem that the sampling distribution of the sample means it approaches a normal distribution as the sample size gets larger. If you see the first diagram of normal distribution, some sinusoidal distribution it came. And that means it leads that the normal distribution, it leads to the sample size gets larger, like in second diagram. So next exponential distribution, the value is getting a more value like a probability distribution of the time between the events in a Poisson point process. That means 2 power and whole power. We are having the values how we are going to perform exponential distribution. The value gets very high value. In that case, we are using this in x-axis. We are taking 0 to 5 and we are calculating probability density exponential distribution. So next chi-square distribution. Why do we want to perform chi-square distribution? The distribution of the sum of squared standard normal deviates. In the case of classification clustering, we used to perform chi-square distribution for testing of all the data samples and the sum of squared standard normal derivatives. Then the discrete probability distribution, we have three approaches like Bernoulli distribution, binomial distribution, and Poisson distribution. Bernoulli distribution is nothing but it's a distribution of a random variable which takes a single trial and only two possible outcomes, namely 1 success with probability p and 0 failure with the probability of 1 minus p. That is called a Bernoulli distribution. If you take binomial distribution is very popular comparatively Bernoulli distribution and Poisson distribution. The distribution of the number of successes in a sequence of n independent experiments and each with only two possible outcomes like head and tail. Namely 1 success with probability p and 0 failure with probability 1 minus p. So that is called binomial distribution. Just like how we are performing a binary search algorithm. The searching element in between low to high, we are calculating the mid position comparing with the low value and mid position comparing with the higher value. The value falls between low or higher the value. Half of the portion we are removing and we are searching the element. That's why the time complexity of binary search is order of log n. That means 1 by 2. That means two possible outcomes we are getting, namely 1 success and 1 failure. Then Poisson distribution, the distribution that expresses the probability of a given number of events k occurring in a fixed interval of time if these events occur with a known constant average rate lambda and independently of the time. That is called a Poisson distribution. If you see Bernoulli distribution in the diagram, so one is a positive and one is negative based on the values we are calculating. So x value is 0, 1 and the getting output value is p and 1 minus p. Then binomial distribution, if you are performing f random variables like x is equal to 0, 1, up to n, otherwise we are calculating the sinusoidal curve. Poisson distribution, same as binomial distribution, but the values are changes according to the distribution. Then the seventh one is a hypothesis testing and statistical significance. It is there are two important concepts we are performing. After completion of our classification, clustering, association, rule mining, outlier detection, we are performing hypothesis testing, whether our model is correct or not. How do you can justify based on the results, based on the outcomes, whether my model is correctly classifying the data or not, based on the null, based on the hypothesis testing we are performing. Like a null hypothesis is nothing but a general statement that there is no relationship between two measured phenomena or no association among groups. That is called no null hypothesis. Alternative hypothesis is nothing but be contrary to the null hypothesis, like in statistical hypothesis testing. A type 1 error is the rejection of a true null hypothesis, while a type 2 error is the non-rejection of false null hypothesis. So if you see the second diagram, we have a type 1 error, type 2 error. So it falls under right side alternative hypothesis is called, you can call it as a type 1 error, or a type null hypothesis. In between the values we are segregating. So null hypothesis, if you see the square boxes like conclusion, we are accepting the null. In some cases H0 is true, then correct. Reject null cases false positive, type 1 error. Like in the confusion matrix, based on the true positive, true negative, false positive and false negative. We are calculating the accuracy. So number of samples are correctly classified by the total number of samples. That is called null hypothesis. Then interpretation means you have got results. How do you are going to interpret the values of the in the graph or any histogram or anything, scatter plot, etc., bar chart. So there we are using three concepts like p-value, the probability of the test statistic being at least as extreme as the one observed, given that the null hypothesis is true. When p-value greater than alpha, we fail to reject the null hypothesis, while p-value less than alpha, we reject the null hypothesis and we can conclude that we have a significant results. That is called a p-value. So critical value is nothing but a point on the scale of the test statistic beyond which we reject the null hypothesis and is derived from the level of significance, that is called alpha of the test. Then significance level and rejection region when we are using while performing interpretation. The rejection region is actually dependent on the significance level. The significance level is denoted by alpha and it is probability of rejecting the null hypothesis if it is true. The Z test, when we are performing Z test, while completion of classification, clustering, association rule mining, outlier detection, we are performing on that model. A Z test is any statistical test for which the distribution of the test static under the null hypothesis can be approximated by a normal distribution, and test the mean of a distribution in which we already know the population variance. That means our model is giving correct or not. Many statistical tests can be conveniently performed as approximate Z test if the sample size is large or the population variance is no. See, one sample Z test means one variable we are calculating. Z is equal to x bar minus mu by sigma divided by square root n. If two variables are there, two proportion Z test we are performing like Z equal to P1 bar minus P2 bar minus P1 minus P2 by square root of P of 1 minus P plus P of 1 minus P divided by N1 plus N2. So these are the Z test we are performing. When we are performing T test, so once we completed our model experimentation on classification, clustering, association, rule mining, etc., that time we are performing T test. It is a statistical test if the population variance is unknown and the sample size is not large, n less than or equal to 30. Then we are using a T test, like a paid sample, like means that we collect data twice from the same group, person, item or thing. Independent sample is nothing but implies that the two sample must have come from two completely different populations. That's why we are performing t-test. One sample t-test means one variable we are calculating like t is equal to x bar minus mu by s divided by square root of n. Paired sample means two variables.
What are the difference between a p and
Yes.
p value as well as a t-test value?
Yes. In order to perform this test t-test for calculation of the population variance is unknown. I don't know how much the data samples are presented in the database or hypothesis. Then we are performing t-test based on the variables like one sample or two samples we are taking. So that time we are using this probability concept like a t-test testing purpose we are using based on the paired sample, based on the independent sample, based on the one variable, based on the two samples. We are performing this Z test and t-test. And ANOVA. ANOVA is one of the technique under SPSS. Sundar, do you know SPSS?
No.
No problem. So especially statisticians, they are using SPSS means Statistical Package for Social Sciences. It is a statistical tool where we can perform population concept by using linear regression, nonlinear regression, logistic regression, and
Is it a
Poisson
SAS
distribution.
tool or a?
Yeah, it's a tool. It's a tool.
Just like SAS tool?
Yes,
Statistics
yes,
analysis.
yes. Yes, ANOVA is nothing but analysis of variance. ANOVA is the way to find out if experimental results are significant. That time we are performing one-way ANOVA, two-way ANOVA. It is a technique under SPSS tool. So one-way ANOVA is nothing but analysis of variance is called one-way ANOVA. So compares two means from two independent groups using only one independent variable. The two-way ANOVA is the extension of one-way ANOVA using two independent variables to calculate the main effect and intersection effect. Like see now treatment. If you are performing sum of squares, we are representing as SST and degree of freedom k minus 1. Degree of freedom is nothing but you can call it as fuzzy. Fuzzy logic is nothing but degree of freedom. That means you can you are giving choice between 0 to 1. How many values are there? 0.1, 0.2, 0.0001, 0.00001. Like that you are giving degree of freedom. Such concept is called fuzzy logic. We are using in soft computing techniques. Mean squares we are using. We are reducing the error while classifying the data, clustering the data, and we are performing a relationship between two variables. So this ANOVA table we are using, and whether the classification or regression is perfectly performed and we are getting experimental results are significant. So that time we are using ANOVA test. Then chi-square test is nothing but it checks the whether or not a model follows approximately normality when we have a discrete set of data points. Suppose I am calculating the population of India and it is giving that model. Suppose I am using a regression model like linear regression or logistic regression and non-linear regression. Approximately it is giving the values and we are finding the normality when we have a discrete set of data points. So that's why we are performing two kinds of goodness of fit test and chi-square test for independence. We are using O stands for observed value and E stands for expected value. So that's why chi-square test formula we are uses x square C. So C here indicates that the chi-square test value. So OI minus EI of whole square sigma divided by and expected instance I value. So these are the testing values we are performing on discrete data set points. If you see the same in counting, we are using two major concepts like permutations and combinations. Like what is meant by permutations? The number of ways to arrange n unique items in R slats, that is called order matters. So formula we are using P of n comma r equal to n factorial by n minus r factorial. Then combinations we used to call it as the number of ways to choose R items from n items. Order doesn't matter here. Whereas in permutations we used to have order matters. Formula for combinations we are using C of n comma r and n factorial by r factorial multiplied by n minus r factorial. Then probability axioms we are using. So here in order to say some value between 0 to 1, you need to have some evidence, like probability is always between 0 to 1. Sometimes you are getting the value 0.5. So there must be a significant axiom or significant value. So if it is P of S equal to 1, that means the probability of the sample space is, S stands for here space and P stands for probability. So if a sample space S is 1, then we can say it as a probability axiom is good. P of A union B equal to P of A plus P of B minus P of A intersection B. This is union of events A and B. So sample space and events. What is meant by sample space? The set of all possible outcomes of an experiment. That is called sample space. Events is nothing but subset of the sample space. If you want to perform some action, some average, standard deviation, etc. Then types of events we have two types like independent events, mutually exclusive events. So independent events nothing but events A and B are independent if P of A intersection B equal to P of A multiplied by P of B. Then mutually exclusive events, events that cannot happen simultaneously, P of A intersection B equal to 0. If you see marginal, conditional and joint probability, we have three types. How do we calculate marginal probability? We have P of A or P of B. The individual probability is called marginal probability. And conditional probability based on the constraints, we are calculating P of A by B equal to P of A intersection B by P of B. Joint probability is nothing but P of A intersection B, the probability of both events happening. Then Bayes theorem is nothing but we have seen already P of A by B equal to P of B by A multiplied by P of A by P of B. Then exception and variance, expectation and variance. We have six concepts. Usually we can call it as a statistical operations. That it comes under expectation and variance. What is conditional expectation? Conditional means constraint oriented. The expected value of a random variable given in some condition, maybe negation, maybe true or positive, maybe greater than, less than. Like conditional variance is nothing but the variance of a random variable given some condition. So that is called some condition. Mean means the average value, median the middle value, mode most frequently occurring value, standard deviation the square root of the variance is called standard deviation. Correlation and covariance we have seen already. Correlation measures the strength and direction of the relationship between two variables. Covariance is nothing but measures how two variables change together. That is called covariance. Then random variables and distribution. We have a discrete random variables, continuous random variables. See the discrete random variables nothing but it is not continuous. Take on a finite or countable number of values like binomial, Bernoulli, Poisson distribution. Whereas continuous random variables take on an infinite number of values, example uniform, exceptional, exponential, normal. Distribution functions we have seen already PMF, PDF and CDF. Probability mass function we can call it as a discrete distribution formula. PDF probability density function that is in continuous. CDF cumulative distribution function. Distributions is nothing but discrete and continuous. uniform or Bernoulli or binomial or Poisson, and continuous uniform and exponential and normal. In both cases, we can see the uniform distribution is common. Then central limit theorem, it states that the sum of a large number of independent random variables approximates a normal distribution regardless of the original distribution. So we are performing hypothesis testing based on the constraints and user requirements and the confidence of interval, that is called an estimated range of values. Z-test, it tests the mean with known variance. T-test, test the mean with unknown variance. Chi-square test the independence of two categorical variables. So in that constraints, we are performing hypothesis testing. Then the last topic in statistics, we are performing regression, eighth concept. Regression means based on the past values, we are calculating the future value. That is the relationship between one dependent variable, usually denoted by y, and a series of other variables known as independent variables. It is a statistical method used in finance, especially investing and other disciplines that attempts to determine the strength and the character of the relationship between one dependent variable, that is usually denoted by y, and a series of other variable known as independent variable. We are classifying the regression 5 types, but majorly we are performing 3 types: linear regression, nonlinear regression, logistic regression. So 4 and 5 are exceptional cases. We are using linear relationship and multivariate normality. So types of regression, if you see the diagram, we have linear regression, logistic regression, polynomial regression, stepwise regression, and lasso regression, ridge regression, and elastic net regression. And if you see the statistics flowchart, it starts with the start and data collection. Once you have a data collection, we are performing data description. That is called a story of what data is all about and the features present in the data. So that is called data description, performing both the statistical and graphical data analysis, data transformation and deviation of new attributes if necessary, selection of machine learning algorithm based on the patterns observation in EDA. EDA stands for exploratory data analysis, data standardization and normalization, creation of train and test data sets using optimum parameters, model training using the machine learning algorithm tested above, calculation of mode accuracy, both training and test accuracies, hyperparameter tuning achieve a better accuracy, saving the created model file, deployment strategies for the model, that is called live streaming, batch processing, mini batch, and the production of deployment and testing, finalizing the retraining approach, logging and monitoring, that is called maintaining and audit tables, dashboard for monitoring and logging reports. Finally, we are performing stop. This is called a statistical operation flowchart. And the first one is a linear regression. So I'm going to demonstrate with the practicals here what is meant by linear regression. If you see, linear regression is a linear approach to modeling the relationship between a dependent variable and one independent variable. An independent variable is a variable that is controlled in a scientific experiment to test the effects on the dependent variable. A dependent variable is a variable being measured in a scientific experiment. A linear regression line has an equation of the form y equal to a plus bx, where x is the explanatory variable and y is the dependent variable. The slope of the line is b, and a is the intercept value, the value of y when x equal to 0. You see the diagram, we are calculating linear regression formula. Yia equal to b naught plus b1 and multiplied by xi plus and sigma, error I. That is called error term. And yi is nothing but dependent variable, that is called response variable. And xi is the independent variable, that is predictor value. B1 is the slope coefficient. and B naught is the y-intercept value. So now I'm taking the problem statement like, for example, let's say we want to model the relationship between the number of hours studied and the score on a test. We collect data on a 10 students and record the number of hours studied and their corresponding test scores. If a student reads 2 hours, he is securing 60 marks. If student reads 3 hours, then he is securing 70 marks, and so on. Like if student is reading 6 hours, he is securing 100 marks. Like if student is reading 11 hours, out of 200, he is scoring 150 marks. How do you can see and solve by using linear regression? See here, using the above data, we can calculate the slope and intercept values using the following formula. We are using B and A, and the formula we are calculating. Why do we want to use B and A? We need to calculate slope and intercept value. Then where n is the number of data points. So after calculating the values of the slope and intercept, so slope value is B and the intercept value is A. We can use them to predict the test score for a given number of hours studied. For example, if a student studies for 7 hours, we can predict their test score being the following formula. That's why we are using linear equation formula. Y is equal to mx plus c. That means, yeah.
Doctor, can you go back to the one slide, please?
See here.
So we already have a 7 here though, right?
Yeah.
Okay.
Means we have collected data points. This is called our studied X, and Y is the test score. This is the sample data I'm taking. I'm constructing linear regression based on the formula Y is equal to mx plus c. Yes.
Okay, but there it's 11 means, yeah, okay. Okay.
Yeah. Now see, I'm
predicting value, but it might
yes,
be
correct.
Right. Based on the probability. Okay.
Correct. For 7 hours, okay. Your doubt is for 120. Just I have taken the sample of data. By using linear regression, the value changes here. See here. Yeah. 7 hours if you study, you are scoring 95 on the test, because in the linear manner, sequence of data points we are calculating. Y is equal to mx plus c. So A value is 10 minus 10 plus B value is 15x. So Y is equal to minus 10 plus 15 of 7. So we are having the value is 105, 15 multiplied by 7, 105. Yep. Then minus 10 hours. Therefore, we can predict that student who studies for 7 hours will score 95 on the test. So same program we are executing. Can you execute, Sundar? I'm sharing this this value to your WhatsApp. Please execute. You can create a linear.py. You just open your WhatsApp. I'm sharing the code. You try to execute while creating in descriptive manner. In descriptive, I mean scripting way you can execute. Please open your yeah.
Sure.
Yeah, you can execute. Please share your screen. I want to check how do you can create scripting way of executing Python programming. Can I stop my screening?
Yeah. Oh, sure.
Yeah. Now you can share the screen. Perfect. So how do you erase this console? I'm asking the question, Sundar. How do you erase this console? Ideally, import space OS. Perfect. OS dot system of CLS. System of parenthesis begin, double quotes begin, or single quotes, no problem. CLS. Yeah, enter. Now quit. QUIT, parenthesis begin, parenthesis close. Parenthesis, yes, perfect. Now you are in scripting way. Notepad space, CLS. Before that, you can perform CLS, clear the screen. Okay, notepad space. Yeah, perfect. Notepad space, linear.py. Linear.py. Yeah, no problem. Linear.py. Yes. Say yes. Now you can copy paste that one because we are saving the time. Otherwise, it typing it takes more time. We cannot cover remaining topics. So you just go to WhatsApp. Yes. Now Control S. Just to do Control S. Yeah. Yeah. Perform Python space. Now you can execute Python space linear.py. Yeah, you need to install. Yeah, no problem. It is saying no module name means pip. You need to install that package because in your Python it is not inbuilt. Now we need to install pip. It's okay. No, not here in the scripting way. Again, you need to no. Here it won't work. Quit parenthesis begin parenthesis close. Quit parenthesis begin parenthesis close. Enter CLS. Clear the screen. Pip means package installation for Python. Pip space install install space numpy. Perfect. Now enter. Now it is going to install numpy package, numerical Python package. Now again do perform Python space linear.py. Enter. Yeah, still matplotlib is because we are generating the graphs. Pip install. This is not an error. It is saying that it's no package. Pip install matplotlib. Yes, enter. Yes, now see the output value. It is generated graph also.
Oh, it's flickering. Okay, come on.
No.
Hold on.
Yeah. Yes, perfect. Now see the
Yeah,
score.
this is a perfect
Correct.
linear regression.
Predicted test score for 7 hours studied. So now you got it linear regression. Yeah. So will you able to execute the remaining 2 algorithms, linear and non-linear and logistic regression, Sundar?
Yeah, the same way. Yes, sir.
Yeah, same way. Can you execute?
Yeah. Are you sending a code or?
Yeah, I'm sending. Wait, I'm sending the code. This linear regression code I'm sending. So I'm sending non-linear. You can give the name non-linear.py and logistic also I'm sending. Yeah. Same problem. How do you can execute? So 2 programs I'm sending. So with this one, I'm concluding today's session, Sundar.
Okay.
I have a small call from
No
India.
worries, no worries.
Yeah. Can I quit the session now? So I'm sending, you can execute. I will explain tomorrow. I'm going to finish tomorrow within 5 minutes statistics. Then we are moving to directly machine learning and deep learning concepts. Then finally we are coming to data science. 16 case studies I'm going to discuss with you.
Okay. Okay.
Okay.
So question is, do you think, are you going to be available at 4 p.m.?
When? Morning?
No, evening.
Evening. For me? Yeah. Why not?
What time? What time are you going to get there?
Sydney time. Are you available morning 7 to 8 at least? Sydney time.
4 o'clock is 11 o'clock for me.
Oh, evening 4 o'clock, 11 o'clock. Oh yeah, 100%. I'm available 4 to 5.
Okay, the 4 to 5 is just like exactly like you are. So for me, it's 11 to 11
so
to
that I can quickly finish your syllabus. Yeah.
Yes.
Okay.
Okay. So if you wanted to come back at 4 o'clock yesterday,
Yeah.
I can come back and do
100%
11, 12.
Yeah.
Okay.
Okay.
Sounds good. Thank you.
Yeah.
Thank you, doctor.